Okay, welcome back to section 11.7. In this question, we want to test whether the series converges or diverges. If you can look, this series consists of two things, polynomial and exponential. So if we go back to what we said before, if we have exponential function, the ratio test seems to be very good test to try. So let me solve this one with the ratio test. For the ratio test, we need to find limit of two things. N goes to infinity. We need to find an plus 1 over an. Now an is already written in the question, which is n squared e minus n. Okay, and an plus 1, it's the same, but you just change every n you see into n plus 1. And that is equal to the limit n goes to infinity. Now if you look at this one, the best way to do is, because there is a negative here and negative here, let me just take them together. So it will be n plus 1 squared e negative n negative 1 over n squared e negative n, and that will be equal limit n goes to infinity n squared, and then on the top we have n plus 1 squared e negative n negative 1, and this negative n, it will go up here with plus, so it will be plus n. We should continue. Limit n goes to infinity n squared n plus 1 squared e. Now if you do the cancellation, negative n negative 1, you just get negative 1 here, and it will go outside, and finally we get this limit. And if you do this limit at home using L'Hopital, this is an easy peasy one, it's equal to 1. Just try L'Hopital twice, you will get 1. So the final answer will be e negative 1, which is we need to compare it with 1. Is it greater than 1 or smaller than 1? This is less than 1. Now for the ratio test, if the limit is less than 1, we say the series converges. By which test? By the ratio test. Okay, that's what we want to do. Let's go to the next question, which is this one. Here again we have kind of a situation where we have a plus here. So why we don't look at every sequence by itself, converges and diverges, converges and diverges, and we check. So let me do it in two parts. Let me try this one first, and then I will check this one. If both of them converges, if I add them, the answer will be converges. If one of them is diverges, if I add them, the answer will be diverges. Now, if you look at the first one, I can say something directly. This is converges. Do you know the reason? Do you know the test? This is a very famous one, very important one, and we all know it. It's the p-test, yes. With p equal 3 greater than 1. We finish from the first part. Now, if we look at this one, okay, here we can use because this is exponential, by the way, so we can use the ratio test, or you can think about it as geometric series. So this is converges because it is a geometric series. Now, if you remember geometric series, it should be sum of something to the power of n. What shall we write here? Of course, we should write 1 over 3. So this is converges because it's a geometric series with r equal 1 over 3 less than 1.